Good morning. So after successfully looking at compound angles, we can now comfortably look at double angles. Hope you have done several examples from the back house and you are now familiar with those concepts. And so double angles simply come from compound angles as you observe. I'll first of all list them down and then prove them later. Sine 2 theta is a double angle which can be expressed as 2 sine theta cos theta after expansion. Cos 2 theta is also a double angle which can be expressed as cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. All those are forms of cos 2 theta once you finish expansion. And finally, tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So we can now prove those double angles. And in our proof we are beginning with sine 2 theta. So you observe that sine 2 theta is the same as, you simply break up that 2 theta. 2 theta is the same as theta plus theta, just like the way we can say 1 plus 1 is equal to 2. And once you observe, this time around it is a compound angle where A is equal to B, which is theta. So once we get the expression for a compound angle of sine A plus B, we simply replace, for where there is A we put theta, and wherever there is B we also put theta to obtain our last expression there, which is sine theta plus theta is the same as sine theta cos theta plus cos theta sine theta. And so at this step you observe that sine theta cos theta is the same as cos theta sine theta, but they have simply interchanged these. They have interchanged sine and cos. So once we put it in the correct way that we understand, you'll observe that sine theta cos theta is the same as sine theta cos theta, and once we add those two, you'll get 2 sine theta cos theta, hence the first double angle for sine. So we move on to cos 2 theta. We do the same thing. We expand for cos A plus B, like in the previous examples that we have looked at for compound angles, and A is also still theta and B is also theta. Once we place them in our equation there, you observe that cos, you get cos squared theta, and sine times sine, you'll get sine squared theta. But remember, for part B now we are proving cos 2 theta is equals to 2 cos squared theta minus 1. We are observing that they are simply using the first one, but they are eliminating sine squared theta. That's why we now need to remember that our first trig identity can help us complete this task, whereby we said cos squared plus sine squared is equal to 1. Make sine squared the subject, put it in the above expression, do the algebra there, and you'll obtain 2 cos squared theta minus 1. And for the last expression it is the same, but this time around we are eliminating cos squared theta. So once you make cos squared theta the subject, place it in the above expression, do the algebra, you'll obtain the last compound angle for cos 2 theta. And then we can complete this by the third or the last for this morning. That is tan 2 theta is equals to 2 tan theta tan squared theta. So we can also use the compound angle for, the compound angle for tan, or simply use the ones for sine and cos. Anyway, you come to the answer. So as I use the compound angle, you'll observe that still A is theta and B is also theta. Put it in that expression, do the simple algebra, and you'll obtain your last expression, which is the compound angle for tan. Thank you.